In this video we will discuss a single phase transformer. Suppose this is primary winding. Number of turns in the primary winding is N1, number of turns in the secondary winding is N2. This is applied voltage V1, output voltage V2. We have alternating voltage V1, current I1 will flow, alternating current I1 will flow in the primary winding, and this is the secondary current I2. This is the flux path set up by the current I1. Phi, as this current I1 will be alternating in nature, this current causes a flux that will also alternating in nature. Phi equal to phi m sin omega t. The EMF will induced in the primary winding due to the Faraday's law of electromagnetic induction. The EMF induced will be given by E equal to d phi by dt minus this. This will be the EMF induced in the primary winding or in the secondary winding. Both the windings, the same EMF will be induced as the flux linked in both the windings is same. So we can say minus n d phi m sin omega t upon dt. We can solve this further. Minus n derivative of sin omega t cos omega t we know that cos theta can be written as sin theta 90 minus theta, can be written as 90 minus theta. So this can be written as minus n sin 90 minus omega t. Here we write this 90 minus theta equal to minus omega t minus 90 . We know that sin minus theta equal to minus sin theta. This is the formula. As with this formula, the above equation, this minus is taken outside, then minus plus n phi m omega sin omega t minus 90. This is the EMF induced in the winding. Suppose here we can say this is the, we can write this as E max. This is the maximum value of any sinusoidal value. Here this is a sinusoidal quantity, E equal to E. This is the maximum value, and then sin. Then we can say that E equal to sin in this format. here E max E RMS. Now we can calculate the RMS value. E RMS equal to E, we know that E max by root 2. This is the formula for E RMS, root mean square value. E RMS equal to E max upon root 2. We can put the value of E max from the above value, and phi m omega upon root 2 equal to n phi omega we can write down 2 pi f upon root 2 equal to n phi 2 pi f upon root 2 equal to 4.44 phi f n. This is the value of ERM. 4.44 phi m f n. So EMF induced in the winding will be proportional to the maximum flux density in the winding and the frequency and the number of turns. So for the primary, in case of primary, it will becomes for primary winding. Now for primary winding, it will be ERMS equal to 4.44 phi m n1, and for secondary ERMS equal to 4.44 n2. Right, so we can say this E1 or we can say that E2. So from these equations we can say that E1 over N1 equal to 4.44 phi m. E2 over N2 equal to 444 m. These two are same, so it means EMF per turn equal to same. EMF per turn is same for primary as well as secondary. This is the EMS equation. If E1 is greater than E2, it is called step down. If E1 less than E2, step up transformer. Thanks for watching the video. This is the EMF equation of a transformer.